You think you know object-oriented programming, but wait, you don't actually know anything at all. That's not until you understand the 4 pillars of OOP. Those 4 pillars being encapsulation, inheritance, polymorphism, as well as abstraction. That's the topic of today's episode, guys. So buckle up, grab your cup of coffee, while I break it all down through interactive material and code examples to further your understanding. If you're ready to take your object-oriented skills up a notch, this episode is for you. All right, enough chit-chat, let's dive in. Welcome back, guys, to another episode of, you guessed it, not me, Code with Josh. And for obvious reasons, I'm Josh. Guys, I'm really excited for this episode. Do me a favor, like this video, okay? Click the like and subscribe, all right? I'm a growing channel. That really helps me out as I have value-packed videos for you guys. And guys, if you haven't heard yet, I just dropped my free Python course for absolute beginners. It's over 13 hours, absolutely free, jam-packed with content for you guys. It's the first link in the description. Head on down there and join today as you get my free Python guide, my ebook that I made just for this course, as well as an interactive learning community to help you through your Python journey. All right, enough of that, right? I'm excited for this topic today of the 4 pillars of object-oriented programming: encapsulation, inheritance, polymorphism, and abstraction. Now, let's jump in to my interactive material as I break it all down for you guys. All right, over to the slides. We need to address what these 4 pillars of OOP are. Now, the 4 pillars of object-oriented programming, as I mentioned, we have encapsulation. Okay, now I just put the really basic terms. I'll break it down further in a few minutes. Encapsulation really is just wrapping up your data. Okay, so all relevant data, we're just wrapping it up. The next pillar is inheritance, right? This is just like we're inheriting something from our parents. Could be eye color, could be hair, could be money, who knows, okay? Same thing. We inherit data from another class. Our next pillar is going to be polymorphism. That's a mouthful, okay? Not gonna lie. Until I got into programming, I didn't even know what this word was. Never seen it before in my life. So if it's a new word for you, it's okay, right? Polymorphism is really an object can have many different forms. So right now, just think cloning, okay? And the last one is going to be abstraction. Now the picture for this, I just tried to find abstract art because I couldn't really find one, right? But abstraction is really showing only essential features. All right, so these 4 levels, it's important, it's key that we have an understanding of these 4 pillars of object-oriented programming. All right, the first pillar, we all know it, but let's take a look, encapsulation. So really encapsulation in simple terms is just wrapping variables and functions together. Now remember, a variable in a class is called a property, and a function in a class is called a method. But encapsulation is grouping relevant variables and functions together so we can build from that. And really explained, right, we wrap up data and member functions while controlling access to them. When and why do we use this? Well, whenever you need to manage complexity, hide implementation details, as well as, limit control to functions in your overall program. All right. Now this code example here is a very basic class car. We have our constructor init, right? Most of the time we want init in a class, okay? Init initialize start, right? So when we create a class, when we create an object, init is automatically ran. Okay, so my examples will have that here. And we have 2 methods in that. On the outside, you can see that I create my car using the class, Toyota Corolla. Who doesn't love a good Corolla? 2020. And then I'm just linking the method, my function, getDescription. We're linking it to our object car. A method and a property must be linked to an object in order to work. All right, that's the first pillar. If you're working with Python, or you have been, right, this should look relatively familiar. Okay, it's like the first real main pillar of OOP. Now the next one is inheritance. Now, inheritance in simple terms, right, is a class inherits properties and methods of another class. So you only have to make the method one time, and then I can pass that to other classes. If we break that down further, right, it's the ability to create a new class from an existing class, all by passing down relevant properties and methods, right? So if we have, for example, a parent class, like in my example here, actually, animal, right? Everything in the world is an animal. You're an animal. I'm an animal. My dog is an animal, right? We could have irrelevant properties like legs, arms, hair, things like that, okay? But then I would make an own class for dog, because dog and person, they're very different. They're unique in their own ways. So the same thing applies here. Now, when and why do we use this? Well, when you want to create a new class that inherits, you basically want to establish some kind of hierarchical relationship between your classes that are all working together. That's why we use inheritance, right? All I'm touching on is single class. You could do multiple class inheritance, which I've actually touched on in my other videos. I'll try and link them, okay? So you can see I have a class animal, right? And then I have a class dog. Everything on Earth is an animal that's living, kind of, right? Just don't be literal, just think about it. And then we have dog, right? So dog, when we speak, it's going to return wolf. But if, for example, if I create two objects, a dog and a cat is a different type of animal. So it's just going to say animal sound because we don't have a cat class. Don't worry, I'll show you through this in VS Code, all right? I have these examples put together, and I just want to give you guys a high-level overview today. Now, our third pillar, this is a fun one, it's that crazy word, polymorphism. Now, by simple terms, it really means to have many forms, right? Cloning. But really, objects of different data types can be treated as objects of a common parent class or superclass. And why we use this when you want different objects to respond to the same call, same message in different ways, right? So for example, I have a parent class animal, okay? I have a method that really just raises an error, okay? I'm raising an error and I'm saying the subclass must implement an abstract method. Then we have our class dog. Now dog only has speak inside, okay? That's it, all right? So I have two classes. Now on the outside, I'm making a function. This function is not related to any class at all, okay? It's a function on its own. In our function, I'm giving animal. Now animal is really going to be an object that I'm going to give to this function. Now that I have an object, I can use a method because a method must be linked to an object. Now, despite the function being unaware of the specific animal type being passed into it, it can dynamically call the speak method that we have in both of these. And this really showcases that polymorphic behavior. On the outside, I call my function, giving it an object. So dog.speak, wolf, polymorphism. Brings us to our last one of abstraction. Now, in simple terms, this is really just showing only essential features, right? If I ask you your name, and I say, hey, what's your name? And you say, hey, I'm Bob, I'm 23, I live in Idaho, and I like potatoes. I didn't ask you for any of that except your name, so I don't care about the other stuff, right? I want to show only the essential answers, features, abstraction. It's really when we showcase those features to the outside world, but we hide irrelevant information. You like potatoes? Sorry, I don't care. Is your name Bob? I asked for that. When do we use this? When you want to provide a simplified interface and promote code maintainability. Okay, this is really good for that. Now, over here, you can actually see I need to import something. So Python has the ABC class from the ABC module, right? Abstract base class. I'm also importing a decorator, okay? If you missed that, I'll link a video here. It talks about decorators at Python. I made that too. And I'm importing abstract method. Now you can see I create a class shape, and the shape is an abstract base class. I create a single method in there, area. But inside area, I put pass, right? So pass just means skipped. I'm going to use my decorator before that, abstract method, so I'm saying that this area is going to be an abstract method. I then can create any shape class, rectangle, square, triangle, circle, you name it. So I create a class called rectangle with area in there. Now rectangle inherits shape. I can run this the same exact way, okay? But think of this parent, this shape class, as a parent. It's our abstract base class. By using abstraction, we can define a common interface for all the shapes to have. This ensures that if I make a rectangle class or a circle class or a triangle, this ensures that because I have an area abstract method, that this new child class must also have a method called that. Okay, so if I make a shape and I want all my shapes to have area, I can make an abstract method here that then it requires all the other classes to have. All right, that was a lot of this. Let's scoot into VS Code. I'll show you 4 quick examples that I've already prepared. All right, guys, if you want this list, I've made this list here for you guys. All right, so everything I'm talking about today, the 4 pillars, it's going to be in this list. And I'm going to put that in the description below. So head down there, get a copy of that you can use when you get stuck on object-oriented programming. Over to VS Code. Our first pillar was encapsulation, and here you can see I have a very basic class. Okay, it's just a single class. I really like travel, so all my examples today I've made about travel. Now we have our travel ticket class, we have our origin, destination, date, and price. For each property, now remember a property is a variable in a class, I have 2 methods. One allows me to get the property's value. So I want to get the origin, I call this method. The other one allows me to change that property's value. So I could get source, get origin, or I could set my origin, right? So all of these methods, functions in a class, this represents encapsulation, the first pillar. Outside, you can see that I've created an object. I could have as many objects as I want. I have an origin, a destination, a date, and a cost. I can then call all the original methods. So get origin, get destination, and it's going to return the initial values. Then all those attributes we can call the other ones, right? So look, I have get price. This returns the initial price. Then I have set price, allowing me to change the initial price. So if I run my code, you can see everything that we're calling here is being output. Here's the original information, and then we modify our destination as well as the price. This is a great showcase of the first entry point to OOP, which is encapsulation. Let's take it up to the next pillar. These work together. The next pillar is our inheritance. How can you inherit something? Why would I want to inherit something? Let's take a look. Here I'm just carrying on. I took my travel ticket, condensed it down a bit, but you can see that every ticket, I can also display information about the ticket. So there's 4 people, right? For each of these 4 tickets, I can call and display specific information for each one, right? But then you see I have another class, right? This travel ticket, that could be anything. It could be a bus ticket, a boat ticket, a flight ticket, a train ticket. So my flight ticket, that's more specific, okay? Now this is saying it's a flight ticket. I'm inheriting everything. So by inheriting, it unlocks access to all this existing information that I can continue to use in the child. Now, in this child, I still create init because I want to inherit all of these from my superclass. My superclass is really the class we're inheriting from. So super initialize all of these existing properties. Then we do this because in this child class, I need to create one unique property that only this child has. So I can do that here. Then I could create the same method. Now, this method has the same name. Boom. Boom. Same name, right? But you can see that I'm adding an extra detail to this one. The first thing we want to do is I want to call my superclass. I want to use my parent class's method, print off this data, then we can link this to the end of that data. All right, so I'm inheriting everything. It's code reusability. Use it one time. Programmers were lazy, right? You can see that I have a single object. I have a departure, a destination, date, price, and an airline. If I run my code, you can see all of our data is being represented from our superclass, the parent, as well as our airline data right there. This is a great entry point to inheritance, all right? That's second pillar. Now we can build the next pillar of this house we're making for OOP. The next pillar, guys, is polymorphism. With polymorphism, I can keep on the same topic, right? Let me unmark these now. Okay, I have my initial travel ticket class. We started with this with encapsulation, then inheritance. I have my flight ticket class. Flight ticket inherits travel ticket. It's the same code. And then I built a new one. Then I have train ticket. Train ticket is still another type of travel ticket. I'm inheriting. So I have one parent class. Travel ticket is like the top of the pyramid. That's the peak. Then everything is being built from the parent class. Okay, so we have our three classes here. Next up on the outside, I make a function. Okay, this is an outside function that anything can use. And despite the function being unaware of the specific ticket, is it a flight ticket? Is it a train ticket? The function doesn't know, right? But that's okay. This is where polymorphism comes into play. This function can dynamically invoke, dynamically call the display ticket for whichever object, because this ticket is the parameter of the function, right? So bear with me. Outside here, I make two different objects, okay? One's a flight ticket, one's a train ticket. I then call my function, giving it an object, so flight ticket. So flight ticket, display ticket info. This is a great use case of polymorphism. When I run my code, you can see that I have flight ticket information, Seoul to Athens, but then I also have train ticket information, Paris to Rome. That's because we used Python's polymorphic behavior. That's so cool, right? That's your third pillar. This is a more advanced concept now, okay? Because most people get the first two in their Python learning journey. Now we're into the last one. Do you remember? What's the fourth pillar of OOP? Abstraction. No, not Van Gogh, just abstraction. Abstraction is a pretty cool one, but you can see the first thing we're doing here is I'm saying from the ABC module, I'm importing an abstract base class as well as the abstract method decorator property or decorator function. Sorry for that. Okay, so here I still have my travel ticket. We've been working with it the whole time, but this time travel ticket is an abstract base class because no matter what type of travel ticket it is, every travel ticket should be able to display the ticket info, right? Like if I go on a cruise, tell me about the cruise. What was the price? How many days was it? If I go on a flight, right? What was the price? How long was the flight? If I go on a bus journey, the same concept. So everything that inherits this superclass, this base class, should have the same method in there. It's like a way to remind myself, hey, you need to make this in all of the children classes that you make from the class. So right here, I'm applying my abstract method decorator to this. Okay, so now everything has to have that. And you can see that I have my flight ticket class, I'm inheriting travel ticket, I'm now expanding. Okay, train ticket, I'm expanding the details, the same thing. Okay, create two different objects, I can then just use it the same exact way. But then Josh, what's the whole point of abstraction? Right, I get it. Okay, let's go up a second. So right here is our ABC, our abstract base class, right? This allows us to define a common interface for all the travel tickets through the abstract method, right? Through this method right here, okay, I'm defining a common interface. This ensures that these two subclasses, 1 and 2, provide their own implementation for this method. It's a reminder, okay? That's the fourth pillar of OOP, guys. Oh my gosh, well done, okay? Now, looking at our code, we talked about our last pillar. Oh, whoa, there you have it, guys. That was the 4 pillars: encapsulation, inheritance, polymorphism, and abstractions. If you guys got value from today's video, do me a favor, hit the like button and subscribe, as that seriously does help me in the YouTube algorithm grow my channel out. all right? And guys, remember, I made a free Python course for absolute beginners, over 13 hours of content, taking you from A to Z. It's the link in the description. Head on down there and join our growing community today of learners. I was really excited for this episode, and I hope you guys enjoyed it too. I cannot wait to see you guys in next week's episode of, you guessed it, Code with Josh. Until next time.